Hello everyone, welcome to Think Global Education Services SAT Math class. Now guys, the topic for today is coordinate geometry. In today's video, I will only cover the very basic of slope. So we'll cover coordinate geometry in few videos. Now in the first video, I'll only talk about slope and few basic stuff that you need to know regarding coordinate, and then we'll continue making more videos on this. Okay, so guys, let's start. So first of all, let's talk about very basic of coordinate. So if I say, let's say this is y-axis and this is x-axis. So this is x-axis, this is y-axis. Now both the axes divide the entire plane into 4 quadrants, which are actually counted anti-clockwise. So this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So they are counted anti-clockwise. And if I say, for example, let's say this is point P. So this is point P in the first quadrant, which has a coordinate of x comma y. So what does this x and y represents? Now this x and y actually represents the distance of this point from y-axis and x-axis respectively. So I can say that this x coordinate is actually nothing but the distance of this point from y-axis. Similarly, this y coordinate is nothing, it is just the distance of this point from x-axis. So that's how we actually plot the points. So this distance is x and this distance is y. So that's how we plot points inside the quadrant. So for example, if the point is 2, 3, that means this distance is 2 and this distance is 3. That's how we plot particular point inside a quadrant. Now guys, I believe everyone is aware with the signs inside the quadrant. As you can see in the first quadrant, both will be positive. That means x will also be positive and y will also be positive. In the second quadrant, x is negative and y is positive. In the third quadrant, both x and y are negative. And in the fourth quadrant, x is positive and y is negative. So I believe everyone is aware of the signs inside the quadrant. What are the quadrants? They are counted anti-clockwise. And how do we plot any particular point inside the quadrant? Now moving forward, if I say, let's understand two very basic formulas, that are distance formula and the midpoint formula. So again, let me draw the coordinates. So this is y coordinate, this is x coordinate, x coordinate, y coordinate. Now for example, if I take 2 points inside the first quadrant, let's say this is point P, which has a coordinate of x1 comma y1, and let's say there is another point Q which has a coordinate of x2 comma y2. Now if I draw the line between P and Q, that's a line segment PQ. Now if I really want to know the distance between PQ, how do we figure out the distance between PQ? Now this is actually the distance that we need. We can directly use the distance formula, but let's understand how this formula is actually developed. So if I take this PQ as hypotenuse and try to draw a right triangle like this, let's try to construct the right triangle. This angle is 90 degrees. Now this point here I can clearly see is y1, and this point here I can clearly see is y2. So the distance, so if I say, let's say this is coordinate r, so the distance between P and R is actually y2 minus y1. Similarly, on x-axis, if I take this point, that's actually x2. And if I take this point, that is actually x1. So do you realize the distance or the QR, that this length is actually x2 minus x1. So now I can see that if I want to figure out PQ, I'll just apply the Pythagoras theorem, that's hypotenuse square is equal to perpendicular square plus base square. So now I can figure out PR is y2 minus y1. So y2 minus y1 whole square. QR is x2 minus x1 whole square. So that's PQ square. So from here I'll get PQ, which is nothing but the under root of y2 minus y1 whole square plus x2 minus x1 whole square. So this is actually the distance formula. Now the distance formula is nothing new. This is just the application of Pythagoras theorem. So from here I understand the distance formula is y2 minus y1 whole square plus x2 minus x1 whole square under root. That's how we figure out the distance between any 2 points. Now, if I want the midpoint formula, if I take a midpoint here, let's say the midpoint is coordinate z, that's the midpoint of P and Q. Now, if I want to figure out the midpoint, coordinate of midpoint, that's coordinate of point z, I'll just take the average of both the points. So that means x1 plus x2 by 2, comma y1 plus y2 by 2. So that's actually the midpoint formula. Midpoint formula. So I believe everyone understood both the formulas. These are very two basic formulas in coordinate geometry. The first one is distance formula and the second one is midpoint formula. Distance formula is nothing but we solve it by applying the Pythagoras theorem, and the midpoint formula is nothing, it's just the average of both the points. So that's how we figure out the midpoint and the distance. Now, moving forward guys, the most important thing that we have in coordinate geometry is the slope. So this video is mostly focusing on slope. Now, what's the formula for the slope? What's the understanding of the slope? Now, we have a lot of different concepts here, but I'll just specifically stick to SAT. What do you need to know in your SAT for your slope? Now, some students say slope is inclination. Some students try to relate slope with trigonometry and they say slope is tan theta. Everything is correct, but let's just focus in the context of SAT. What do you actually need to know? Slope is actually denoted by m, and the very basic formula for slope is change in y over change in x. That's the formula for the slope, where m represents the slope. So change in y, I can say change in y coordinate, so I can say y2 minus y1 over change in x, so I can say x2 minus x1. That's the formula for the slope. Now, since it is change in y, I can also say y1 minus y2. But be careful, if you take y1 first, then in the denominator, you have to take x1 first. So I can say x1 minus x2. So it does not make any difference, but you have to be very careful that you have to fix the order. So if you start with y2, make sure you start with x2. If you start with y1, make sure you start with x1. So change in y over change in x will give you the slope. Now there are few key points that you need to remember regarding the slope. So if I say, for example, I'll draw the coordinates. So let's say this is x-axis, this is y-axis. Now if I draw a line which is parallel to x-axis, if I draw a line which is parallel to x-axis, so what will be the slope of this line? I should directly know the fact that if a line is parallel to x-axis, the slope is 0. So as I can understand, the basic definition of slope can be understood like this, that it's nothing but the inclination of the line with x-axis. But I can see there is no inclination here. The line is parallel to x-axis, and if the line is parallel to x-axis, the slope will be 0. Now we can understand this mathematically also. For example, if I take 2 points on this line, so I can clearly see that from this point to the second point, is there any change in y? There is no change in y. The y coordinate is same, but there is some change in x. So change in x is there, but change in y is 0. And as you know, the slope is nothing but change in y over change in x. Since change in y is 0 over change in x is something, so 0 over something will always be 0. So if a line is parallel to x-axis, it will always have slope as 0. Okay. So another scenario. So this time, if I say, so I draw the coordinates, x coordinate. So this is x coordinate, this is y coordinate. This time I say that the line is actually parallel to y-axis. So this is the line. This time the line is parallel to y-axis. If the line is parallel to y-axis, the slope is infinite, or I can say undefined. You can say infinite or you can say undefined, same thing. Now we can understand this mathematically also. So if I take 2 points on this line, so I can clearly see that from the first point to the second point, is there any change in x? There is no change in x. The x coordinate is fixed here, but I can see that there is some change in y. So the formula for the slope is change in y over change in x. So change in y is something over change in x is 0. So something over 0 is undefined. So a line parallel to x-axis, the slope will always be 0. A line parallel to y-axis, the slope is always undefined. So these are very basic points, guys, and this is very important because every question in your coordinate geometry in SAT will start from slope. So in overall every question, you need to know the slope. Okay. Now moving forward, if I say, for example, 2 lines are parallel. For example, if the scenario is this, 2 lines are parallel, it's pretty much understood that if 2 lines are parallel, they are equally inclined to the x-axis. So let's say this is the first line has a slope of m1 and the second line has a slope of m2. So if 2 lines are parallel, their slopes will also be equal. So m1 will also be equal to m2. Now if 2 lines are perpendicular, so if I just try to draw the perpendicular lines. So if 2 lines are perpendicular, what is the relationship between their slope? Let's say the first line has a slope of m1 and the second line has a slope of m2. So these 2 lines are perpendicular. So what is the relationship between their slopes? So if 2 lines are perpendicular, so I can say the product of their slope is -1. So if 2 lines are parallel, their slopes will always be equal. If 2 lines are perpendicular, the product of their slope will always be -1. Or I can say they are negative reciprocal. They are negative reciprocal of each other. So same thing, either you say negative reciprocal or you say the product is -1. That's the same thing. So I hope this is clear, guys. Very important. A line parallel to x-axis, slope 0. A line parallel to y-axis, slope undefined. 2 lines are parallel, the slopes are equal. 2 lines are perpendicular, the slopes are negative reciprocal of each other, or I can say their product is -1. Okay. So guys, moving forward in detail for slope, let me draw the coordinate one more time. So here, so I'll just draw a scenario and then we'll try to compare the slopes. So I've drawn the coordinates. This is x-axis, this is y-axis. Now if I draw two lines, let's say this is the first line going something like this. Let's say this line has a slope of m1. Then I'll draw the second line, which is something like this. Now it's just a rough sketch. Okay, it's just a rough sketch. So this line has a slope of m2. Now by just looking at the line, can I decide that which value will be greater? M1 will be greater or M2 will be greater? Now here, by just looking at the line, I can directly say that M1 is definitely greater than M2. The value of M1 will definitely be more than M2. Why I can do that? Because I know that M1 is an ascending line and M1, no matter whatever you do, will always be positive. An ascending line will always have a positive slope. Similarly, a descending line, which is M2, the slope is M2, will always be negative. If I compare the values, positive will always be more than negative, and hence the value of M1 will always be greater than M2. So the descending line will always have a negative slope. So an ascending line always positive slope, a descending line always negative slope. Now, how do we actually analyze whether the line is ascending or descending? So guys, always remember, sometimes student says, okay, this blue line is also ascending, it's going up like this. No, that's not correct. Understand this, you will only analyze whether the line is ascending or descending while moving towards right. So while moving towards right, if your line is going up, that's an ascending line. If the line is going down, that's a descending line. So you will only analyze while moving towards right. So while moving towards right, if your line is going up, that's an ascending line. If the line is going down, that's a descending line. I hope this is clear. Or I can state it in different words. I can say that you will only analyze in the first and in the fourth quadrant. So basically only on the right hand side. So you will only analyze the line on the right hand side. That means only in the first and fourth quadrant. If in the first and fourth quadrant the line is going up, that's an ascending line. If the line is going down, that's a descending line. So that's a very basic idea to figure out that which slope will be positive and which slope will be negative. Now here we can understand this mathematically also. For example, if I take 2 points on this red line, if I take 2 points, something like this, so I can clearly see that from the first point to the second point, x is increasing. From the first point to second point, x is increasing and y is also increasing. So it's pretty much understood that if y, the change in y is also positive and the change in x is also positive, and this formula for the slope is change in y over change in x. So change in y over change in x, and in the red line I can clearly see that change in y is also positive and change in x is also positive, hence the slope will always come out to be positive. In the similar context, if I try to take 2 points on the blue line, so from this point to this point I can clearly see that x is still increasing, but here y is actually decreasing. So in this particular case, the change in y is definitely negative and the change in x is definitely positive. So in this case, the slope will always be negative. So we can understand this mathematically also, that an ascending line will always have a positive slope and a descending line will always have a negative slope. Otherwise, I'll just look at it and I know, whichever line is increasing will always have positive, whichever line is decreasing will always have negative. but be careful, you will only analyze while moving towards right. So I hope this is clear, but just going one step ahead. So if I just quickly draw the coordinates again, so ascending and descending is pretty easy to analyze, that the line going up is ascending, so positive, line going down, that's descending, negative. But for example, let's say this is x-axis, this is y-axis. Now this time I try to draw two ascending lines. Let's say this is one ascending line, the red one, which has a slope of m1. And let's say I draw another line which is blue, and this line is also ascending. So both lines, if you see, are actually going up. Now I know both m1 and m2 will be positive because both are ascending. So in this case, how will I judge that which value will be greater, m1 or m2? So guys, there's a direct funda you can directly relate. More ascending is equal to more slope. More ascending is equal to more slope. So I can clearly see that m1 is more ascending here. So m1 will definitely be greater than m2. More ascending, more slope. So the line which is actually, more inclined with x-axis. So I can clearly see that this angle is definitely more. So this line is more inclined with corresponding to x-axis. So m1 will definitely have more slope than m2. So that's interesting, guys. Ascending, descending to identify is pretty easy. But if both the lines are ascending, I should be able to figure out that which line will have more slope. Similarly, let's take one more example, which is much more interesting, that if both the lines are descending. So I've seen students get confused in this kind of example. So let me just quickly draw it. So I've drawn the coordinates. This is x-axis, this is y-axis. Now this time I'll try to take both the lines as descending. Let's say this is one line red, which is descending, and there's another blue line which is something like this. Let's say, so you realize both the lines are actually descending. So this line, let's say, has a slope of m2, and the red line, let's say, has a slope of m1. Now which value will be greater, m1 or m2? I know since both lines are descending, so definitely m1 and m2 are both negative for sure. But which one the value is more? Is m1 greater or m2 greater? So guys, just remember, whatever you do for ascending, just do the opposite for descending. So I can say more descending is equal to less slope. So just remember this reference, that more ascending is actually equal to more slope. Similarly, do the opposite for descending. More descending, less slope. So which line is, I can see, is more descending? I can clearly see that m1 is more descending. So that will definitely have less slope. And in this case, m2 will actually be greater than m1. So which line is more descending? The red one is more descending. So this line is actually more descending. So if it is more descending, that will actually have less slope, and the value of m1 will be smaller in comparison to m2. So I've seen students getting confused with both the descending lines. So if you just remember the reference carefully, more ascending, more slope, more descending, less slope. And for ascending and descending, I believe it's pretty clear. Ascending positive, descending negative. So I hope, guys, this funda of slopes is clear, right? So let's do some questions and make sure how these questions come in your real SAT. Now, guys, this first question. It says in the above figure, line L1 passes through the origin. So I can clearly see that L1 is actually passing through origin, that means 0, 0. And point B, the coordinate is already given, -3, 1. Which of the line, what is the slope of line L2, which is not shown? So I don't know what is line L2. That is perpendicular to line L1. Okay, so they have given me that information that L2 is actually perpendicular to line L1. and I need the slope of line L2. So basically I need the slope of line L2, which is missing, and they have mentioned that L1 is parallel, perpendicular. So guys, can I figure out the slope of line L1? Yes, because that's simply change in y over change in x, change in y over change in x, and I know two coordinates in line L1, that is -3, 1 and 0, 0. So I can directly apply it. Change in y, that's y2 minus y1 over x2 minus x1. So the slope comes out to be -1/3. That's the slope of line L1. But am I looking for slope of line L1? No. I am looking for the slope of line L2. And I know since two lines are perpendicular, the slope of line L1 into the slope of line L2 will always be -1. That's what we learned. If two lines are perpendicular, their slope, the product of their slope is -1. So I know the slope of line L1 is -1/3. I just need the slope of line L2. So from here, I'll directly get the slope of line L2, which is -1 times 3 over -1. So basically minus minus will go. So the slope of line L2 will come out to be 3. So this question was just teaching me that if two lines are perpendicular, what to do. So I know that if two lines are perpendicular, the product of their slope is -1. I'll directly apply it. I know the slope of first line. I can directly get the slope of another line. Or you can directly see there's a negative reciprocal. If I know the slope of one line is -1/3, if I directly do the negative reciprocal, I'll get 3. That will be the slope of a line which is perpendicular to line L1. So I hope guys this question is clear. So moving forward to the next question. Now again, I can clearly see the lines are parallel here, and that's what they are also actually saying. As shown in the XY plane, if line M is parallel to line N, what is the value of A? Okay. So here, what do I know? I know that line M is passing through origin, that's 0, 0. And M, the coordinates are also given to me. So can I figure out the slope of line M? The slope of line M, that's y2 minus y1 over x2 minus x1. So that's 2 over -3. That's the slope of line M. Now, since I know the fact that if two lines are parallel, their slopes are equal. So I can say slope of line M is nothing but slope of line N, which is actually equal to 2 over -3. Because two lines are parallel. Parallel lines will always have slopes equal. That's what we learned. Now, I can directly apply the formula for the slope of line N, that's y2 minus y1 over x2 minus x1. So I can say y2 minus y1, that's 2 over 0 minus a. So that's 2 over -3 is equal to 2 over -a. Negative will cancel out, 2 will cancel out, and I'll get the coordinate of a as 3. So if we see, this question was just dealing with the fact that if two lines are parallel, their slopes will always be equal. So slope of line M is equal to slope of line N. I know the slope of line M, and hence I know the slope of line N. I just equate it with the formula and I'll get the missing coordinate. I hope this question is clear. Now moving to the next question. So guys, this we already did. In a figure above, line PQR has a slope of A, B, C respectively. So let me quickly label it. So line P has a slope of A. Line Q has a slope of B. And line R has a slope of C. Which of the following is true? Now, if you look at this carefully, line P is actually ascending line. If the line is ascending, the slope will always be positive. Similarly, I can see that line Q is descending line. So that means descending line. So that means that C or B will always be negative, because the slope of a descending line will always be negative. And line R, I can clearly see that's parallel to x-axis. And if I already told you, if a line is parallel to x-axis, the slope will always be 0. So from here, I can clearly see that A is positive, B is negative, and C is actually equal to 0. So which option matches this? So the smallest possible value is B, then C, and then A. So the order is smallest is B, then we have C is 0, and then we have positive, that's A. I can clearly see that's option number C. So you can just look at the line and tell, okay, whether this will have positive slope, whether this will have negative slope, or whether the slope is 0. I hope this question is clear. Guys, taking one more just to make a point that how the question actually appears in your SAT. It's a language game. They are saying the line L crosses neither the third quadrant nor the fourth quadrant. So let me quickly draw the quadrants here. And I know the third, so this is x-axis, this is y-axis, this is the third quadrant, and this is the fourth quadrant. Now the question says that the line crosses neither the third quadrant nor the fourth quadrant. And they are also mentioning it is not one of the axes. Of course, it's a different line and it's not crossing the third quadrant and the fourth quadrant. What is the slope of line L? Now, guys, common sense, if I want to draw a line that never crosses the third and fourth quadrant, do you realize it actually has to be parallel above x-axis? So this will be the line L. Because if I want that line should never cross the third and fourth quadrant, that means it has to be parallel to the x-axis. Because if it is slightly tilted, it will definitely cross the x-axis somewhere. So if it is slightly tilted like this, it will cross the fourth quadrant. Or if it is slightly tilted like this, it will definitely cross the third quadrant, which I don't want. So I don't want the line to cross the third quadrant. I don't want the line to cross the fourth quadrant. So the only possibility is it has to be parallel above origin. And we all know that if a line is parallel to x-axis, what will be the slope of that line? 0. That's it. That's my answer. So that's a very basic aspect. They're just trying to say that the line is parallel. And if I know that, I know the slope, that is 0. So guys, that's it from the slope. I hope you enjoyed the video. We'll make another videos to talk about more aspects of coordinate, that is equation, and a lot of other things. So this is just the one video out of it. Thank you guys. Have a good day. Bye bye.